Hi, welcome to Advanced Physical Science. Today we're starting to talk about terms, units, variables, and equations. The objective for you is to be able to identify those things from any given problem or situation. So let's start with terms and their definitions. Distance is the amount of space between two places or things. Displacement is the change in the position of an object. Length is the measurement of an object or space in one dimension. Those three things could be interchangeable. Speed is the magnitude of the velocity, the travel of a distance over a period of time. Velocity is the speed of an object in a given direction. Acceleration is the rate of change of velocity. Time is an infinite continued progression of existence and events. These are all of the terms you're going to be needing to memorize and know. Now, each of those has a unit that goes with it. Distance, displacement, and length are all measured in meters. Speed and velocity will be in meters per second. Time is measured in seconds, and acceleration is in meters per second, sometimes referred to as meters per second squared. The variables that go along with those, and there can be multiple, in general, a naught, that's a lowercase 0, stands for the initial or the beginning, and a triangle stands for the Greek letter delta, which means change in. So velocity is represented by v and v naught, v being the final, v naught being the initial. Delta v is v minus v naught. Acceleration is represented by the letter a. Distance, displacement, or length. Distance, primarily, is x and x naught for horizontal motion, y and y naught for vertical motion. Displacement is represented by a delta x or a delta y. Again, finding delta as being final minus initial. Time is represented by the letter t. Now let's look at your equations. You'll have 4 primary equations. Equation simple. This is kinematic simple. X is equal to x naught plus vt, where x is the final position, displacement from the origin in meters. X naught is the initial position, again, not always at the origin, again in meters. V is the velocity in meters per second, and t is time in seconds. Kinematic 1 is v is equal to v naught plus at, where v is the final velocity in meters per second. V naught is the initial velocity in meters per second, a is the acceleration in meters per second, and t is time in seconds. Kinematic 2 is x is equal to x naught plus v naught t plus 1/2 at squared. Again, remember that x is for horizontal motion, and those would change to y's for vertical motion. X is the final position, the displacement from the origin in meters. X naught is the initial position in meters. V naught is the initial velocity in meters per second. T is time in seconds, and a is the acceleration in meters per second. Kinematic 3 is v squared is equal to v naught squared plus 2a delta x, or x minus x naught. V is the final velocity in meters per second. V naught is the initial velocity in meters per second. A is the acceleration in meters per second. X is the final position or the displacement from the origin in meters. And x naught is the initial position in meters. So here's your problem setup. You're going to look at the terms, units, and variables, and then we'll get to those equations pretty soon. This is a list of what is given in the problem. You're going to highlight or mark them in some way, what is given, and then fill in the rest of the chart. One of the primary problems in any advanced science class is being able to pull the information correctly from the problem. So let's look at a sample problem. A rectangular field is 100 meters by 50 meters. A man walks the perimeter of his field in 112.2 seconds. At what velocity did he walk? Here's what you need to do. Your task is to identify the terms, units, and variables that are represented in the question and mark those. So this is a Tuve chart where you'll notice that we're given M is meters, S or SEC is seconds, and we're given the term velocity. So by filling in the rest of the chart, you can determine what equation should be used in order to solve the problem. The M that was given is distance or displacement, representing x and x naught. S was seconds, representing time, variable of t. Velocity that was given is meters per second based on the units that are already given, and the variable would be v. Based on the variables necessary for the question, the equation that we would use would be kinematic simple.